Let me welcome you to the third lecture of surface mining technology. In this lecture, we will concentrate on the stripping ratios and pit layouts. There are 3 lectures corresponding to this stripping ratios and pit layouts. So, this is the first lecture in this, and this is also a part of the introduction to surface mining. This part is already discussed with you, but every lecture should contain this, the learning background of the surface mining technology, the objective of learning the surface mining technology course, and what will be the outcome of the surface mining course after learning this, what will be the outcomes. These are the textbooks, reference books. Let us retrospect what we have learned so far in lecture number 1 and lecture number 2. In the previous lectures, we understand the current scenario of surface mining worldwide. We also came to know about the rock mass, minerals, ores, along with the economic perspective of the mining. We understood that mining is a very important activities. This is the basic industry. Without this, nation and the civilization cannot sustain, and its economic importance is very economics importance is very high for the growth and development of a country. Now, learning objective of this lecture, this is not only for this lecture, all these 3 lectures of stripping ratios, to know the different terminologies of surface mining operations, to understand the importance of stripping ratio, and to understand the basics of surface mining layouts. Layout means basically the plans and figures. So, we will understand this gradually. So, before starting the stripping ratio, let us try to have some idea about the deposit, because in last class we have already described about the mineral reserve and resource. So, mineral reserve and resource we understand. Now, let us try to understand what is called a deposit. Deposit means basically the way the minerals are occurring in the earth's crust. So, that means the way the mineral is lying, the way, suppose this is the earth crust, and below which a mineral may lie like this, a mineral may lie like this, or a mineral may lie like this. So, the way a mineral is lying inside the earth crust is basically considered as the deposit. So, deposit can be classified based on its positioning and in situ distribution, or it may be classified by its way of origin. So, this there is no particular formula or rule how the deposit will be lying inside the earth crust, but depending on that there may be different types of deposit, but some of the common deposits can be named as massive deposit, bedded deposit, vein deposit, columnar deposits, etc. On the basis of its origin, the deposit can be classified as hydrothermal deposit, magmatic deposits, massive sedimentation deposit, contact mesomatic deposits. So, these are the different way of formations, and because of these formations deposits are having some different characteristics, and based on this the deposit can be classified like this. So, we will see in the next few slide the way the massive bedded vein deposits are basically showing. This is basically the massive deposits. You can see how these massive deposits are formed. These massive deposits may be when the magmas are basically spreading like this, and this portion is remaining, and this is generating a massive deposit. Or sometimes a deposit was like this and finally this portion is eroded, and this was, as it is a strong one, is standing like this. This is also called massive deposit. So, there are different way a deposit is occurred in a massive formation. In that deposit is called massive deposit. These are the different origins, the magmatic segregations, massive sedimentations. In these cases, this type of massive deposits may occur. This is called vein deposit. Mostly you will find out the hydrothermal deposits are formed like this, where the joints are filled with the materials, and this is hydrothermal deposits are accumulation of the valuable minerals which formed from the hot water circulating in earth crust through fractures. And there are, you will find out most of the metal sulphide deposits are occurring like this and gradually supersaturated and then precipitated as the ore minerals. Often you can find out the contact metasomatic deposits are also occurring in the vein form, where the magmatic when the lavas or magmas are flowing towards the cracks, that is changing the other surrounding rocks and also depositing in that cracks and creating the veins like this. So, that is often called dikes also. So, in that cases the deposits are also occurred often in a similar way. Now, in a nutshell you can see a bedded deposit can be termed like this, which is more or less systematically spreaded over an area. Massive deposit is a huge dimension in thickness, in spreading, that deposit is called massive deposit. Bedded deposit, the thickness is thin, but it is spreaded over an area, that is called bedded deposits, and vein deposit is an highly inclined deposits occurring in a vein. So, that is why the width range is not that much significant, but the vertically it is spreading over a significant distance. So, this is the basic characteristics. Massive deposit is having all three dimensions are very large. Here the vertical dimension is not significant, but the spreading over an area which is significantly larger. Here vertical dispersion is much more, but the horizontal dispersion is not that much significant. So, this is the basic characteristics of the three deposits, that is massive deposit, bedded deposit and vein deposit. Now, let us have some idea about the surface mining. If the mineral deposits are occurring in the earth crust, say this is a vein deposit showing here and this is a bedded deposit showing here. Okay. So, if this is the case, then how we are carrying out mining? Say when we are carrying out mining just under the sky, then it is called surface mining. So, surface mining means just in the above sky is there. So, that is subjected to rain, subjected to temperature change, subjected to change in the daylight, and all these things are basically impacting on the surface mining operation. Whereas, in underground mines we create an opening, vertical or horizontal or maybe spiral opening. From there we enter into the underground and carry out mining there is called underground mining. So, underground mining does not have any effect what is going on in the surface, whether the changes, temperature changes, raining, if these atmospheric changes are not impacting on the underground mining, but these are impacting on the surface mining. Underground mining obviously it does not have the illuminations like surface mining. Daytime the illumination is good, the operation can be carried out, widespread visibility is there. In underground mines it is a dark, only artificial lighting system has to be provided, then only the machines and manpower can operate there. This is the basic difference between the surface mining and underground mining. In surface mining, as you have to carry out below the sky. So, in that case all the waste rocks which are available or which are lying above the main desired ore or mineral whatever we are going for mining, that has to be removed first. So, you have to remove first the waste rock, overburden rock which are situating above the ore body, that has to be removed first, and then the main mineral has to be removed. But in case of underground mines, you can say you can, without excavating the waste rock, you can directly enter into the ore body portion and you can excavate the ore body only. So, that is the benefit of the underground mining. So, let us have some look into the surface mining and underground mining. This is a small video, animated video. You can see this is the excavation is carried out in a surface mine. This is animated, this is not the real one. So, this is excavation is carried out. You can see the floor is being basically cut by this machine, and this machine is cutting the material. After cutting the material, the excavator is coming and the excavator is gathering the material. Then after that it is loading the material onto a truck. So, you can see every operation is going on just below the sky, and you can see the quality of the ore, position of the ore, position of the other machines. So, the visibility is also good, working space is very large, and the operations can be made very easily in the surface mines. That is why, as there is no dimensional restriction, you can go for deploying huge dimension machines, big machines can be deployed in the surface mines to achieve the high production and productivity. So, this is for the surface mine. Let us see some operation of the underground mine also. See, in the underground mines, the similar way we have coming out from the surface, then from surface to the ore body we are creating the access. This is the access is made. Our small size machines are deployed in this case. Say you are carrying out blasting at this position. See, this your machine, small machine is coming because your dimension is restricted. In underground you cannot have a very large dimension opening because the supporting cost is required. You cannot have, without supporting the roof you cannot create an opening. So, that is why your supporting requirement is there, that is why dimension is limited, and that is not allowing the deployment of the large machines. Small machines are deployed, and you can see the small machines are taking the material after the blasting. Now, further problem is that whatever material you are taking it out, that has to be taken out, from the shaft, from this shaft which is made. So, the total production target of the underground mines is restricted with the capacity of the shaft. That means, in one day how much material can be taken out from this shaft, that is basically capping the production target of the mine. So, that is why this is the limitations of the underground mines. Now, in a nutshell, let us look into the features of the surface and underground mines. Surface mines are highly productive. The surface mines are economic also for the shallow deposit. The large scale mechanization is possible, there is no restriction on the dimension, and because of the better visibility, better communication, the safety and risk control is better, and this is very good for the mining of the fuel minerals, because if it is burned also, whatever the gases are generated, that is not creating a polluting environment, because it is dispersed into the atmosphere. But if it is happening to the underground, then it is creating a carbon dioxide and carbon monoxide filled atmosphere environment. In underground mining, the benefits are that environmental impact is less. That means, in surface mine, if you are generating some dust, that dust is going to the atmosphere, but here the dust etc. are limited to the underground environment only, it is not coming out and polluting the surface environment. The land requirement is not significant, only you need a small space to construct the shaft. In surface mine, you are having square kilometer leasehold area is required, because your dimension of the mining is very large. Minimum excavation of the waste rock, you need not to spend money on excavation of the waste rock, only the shaft etc. are constructed in the waste rock. Post mining restoration is also easy, because you are not degrading the land of the surface, and this is very suitable for the deep seated deposit, because the overburden excavation or the waste rock excavation is not significant. In surface mining, you have to take out all the above rock cap before take out the original mineral or ore body. So, that is why if it is a deep seated, that means the rock cap is very high, in that case the excavation requirement is very high in the surface mines. So, the drawbacks of the surface mining is the large surface land requirement, and especially a highly populated country or where the forest land etc. are there, land acquisition is a big problem, and that is the greatest challenge nowadays in surface mining. It is unnecessarily removing the waste rock cap, which is lying above the main mineral, and it is having environmental impacts, that is the groundwater is being disturbed, your environment is being disturbed by generation of the dust, generation of the sound. These are basically annoying the local populations. Then post mining ground restoration is another problem, because this large area which is being mined, that has to be restored for the future use. Drawbacks of the underground mines are there: production rate is limited, access to the mine is difficult, low scale mechanization, hazardous operations, safety is very difficult, illumination is less, mining cost is much higher, and it requires ventilation and air conditioning for the better work environment. So, basically you understand, for a shallow deposit, surface mining is no doubt very profitable, very economic, and popularly people are asking for that. But we are having a little bit doubt that in a deep seated deposit whether we should go for surface mining or underground mining. But the problem is, I believe that this discussion should be based on the mathematical calculation, economic analysis. It should not be carried out based on some remote idea that in a deep mine surface mining cannot be carried out, in shallow mines only it can be carried out, because we are having the example that Bingham copper mines is working at 1.2 kilometer depth. Other few mines are also working in 800 meter depth, 600 meter depth. So, surface mines has been found are operating at very deep condition also with significant profit. In Germany, the lignite mine is operating at 500 meter depth also. So, that is why these are very important, and this must be taken care while someone is deciding on the whether you should go for a surface mining or you should go for the underground mining operation. So, we will come to more discussion related to this. We will find out how this judicial decision can be taken on this surface mining and underground mining, choice between surface mining and underground mining in our next class. Thank you.